Hello, my name is Darren Thomas, and I am the Director of Educational Research Techniques. In this video, we're going to take a look at properties of negative exponents. So let's get started. All right, so we've dealt with exponents before, and let's just say we have an example 2 over 2. Oh, let me get this worked out. So we got 2 squared over 2 to the 5th power. Now, you guys know, if you've seen the prior videos, that in this situation, because the numerator is big, the denominator is bigger, it will work out something like this. So you'd have 2, 5 goes first, minus 2. This will equal 1, 2 to the 3rd, which equals 1 over 8. All right, that's what we know. We know that this works. Now, but here's the thing. If we wanted to make this, instead of it being a fraction, if we wanted this to be a base with an exponent or an exponential or whatever you want to call it, well, what happened essentially is that, if you know just from dealing with this, from dealing with math, you know that 1 over 8 is 2 to the negative 3. That's what's happening here. Now, let me show you what's happening in the long form here. So I have 2 times 2 over 2 times 2 times 2 times 2 times 2. It's the same as what we did up here, but now I wrote it out the long way. And so what's happening basically is that this cancels out, and you're left with 1 on the top, and then you have 2 to the 3rd right here, just like so. That's what you have. And of course, we already know that this works out to 1 over 8, and of course, it goes to 2 to the negative 3rd if you want to base an exponent like so. Now the question is, why do we do it like this? Couldn't we have just subtracted? Because, you know, it's very clear. 2 minus 5 equals negative 3. And that's correct. If you take this, 2 minus 5, you clearly get a negative 3. And we could have got that from the beginning. But there's a little trick, there's a little property that's happening here that I want to try to clarify. And it's called the property of a negative exponent here. And so what's happening is, this is the expression, the algebraic expression for this. A to the negative n equals 1 over a to the positive n. That's what's happening here. And of course, right now, this is kind of abstract. So let me see if I can give you an example. Let's say my a is 2. All right. And let's just say my n is 2 as well. So this means now I have 2 to the negative 2, like so. And I have 1 over 2 to the 2. All right, so what's happening here? Well, it's very, very simple. 2 to the negative 2, if you were to put that in the calculator, you would get 1 over 4, like so. Now, the question is, what's happening here? Well, you have, with this guy right here, this 1 over here, another way to write this would be as follows. So the top number is 1 over 1, basically. And the bottom number is going to be divided by, let's see here, 4 over 1. Now, why did I do 4 over 1? Because when you square 2, you get 4. So this is kind of what's happening. Now, here's the thing. Let me do this in a different color. I'm trying to make this as clear as possible here. Make this clear. Now, here's what's happening. So we have 1 over 4 equals, now whenever you divide fractions, you multiply them and you flip the second number. And so now you can see this is why we get this answer. This very, very clear, simple answer right here. Because this is what we're doing. So when you take a base with this negative exponent, it's the same as having the top number being a fraction of 1 over the base times the positive exponent. That's what's happening. And we worked it out right here, because 1 over 2 to the second is the same thing as 1 over 1 divided by 4 over 1. That's what we're doing here. And when you work that out and when you multiply, you get the same answer. That's what's happening. Now, I want to show you this. What happens when your base, when your base is fine, but now you have a positive exponent? What happens here? Well, the opposite is not that hard to believe, but now it's going to be a to the negative n, like this. And so let me work out an example for you. So we're going to use the same two numbers. We're going to have a base of 2, and we're going to have an exponent of positive 2 this time. And we're going to have 1 over a base of 2, and this time negative 2 right here. And so let's work this out real quick. So we know that 2 squared, 2 squared is going to be 4, like so. And then that's going to equal, what's it going to equal? It's going to equal 1 over 4, okay? Now this time, it makes a lot more sense to do the division with the fraction here because we have two fractions. On the previous screen, it was kind of weird because I took this right here and I broke it into a fraction, and that might have been confusing for people. But to show you, or to prove the property, if you will, it was required to do that even though it doesn't really make sense in the real world. All right, so now we have this. So we know that 4 equals 1 over 1, that's taking this top guy right here, divided by 1 over 4. Okay, and you know from taking other algebra courses that when you divide fractions, you multiply them and you flip the second one. So I end up with 1 over 1 times 4 over 1. And so you can see right there that the answer is 4, and that's how it works. And so this is how the property of exponents, property of negative exponents works. In that when you're dealing with these different bases and exponents, if you ever need to convert a base with an exponent to a fraction, this is the trick. Whenever you need to do that, this is the trick when the exponent is positive. Now, if the exponent is negative, this is the trick right here. And sometimes when you're working with different algebraic expressions and equations, it may be necessary to convert for the sake of calculating something, and it can save you a lot of time. So in this video, we looked at the property or the properties of negative exponents and how you can take any fraction and subtract the exponents to figure out what it is. But what ends up happening is that you end up getting often a fraction, and maybe you want a base with an exponent, or vice versa. And so by understanding these properties, you're able to move back and forth between these two expressions of the same value in different ways. So what you have to keep in mind is that if you are starting with a base with a negative exponent, you end up with a fraction where 1 is the numerator, and then the base, the denominator is the base with now a positive exponent. And of course, the opposite is true as well. If you have a base with a positive exponent, if you need to convert it to a fraction, or if you have to deal with the fraction, you still have 1 in the numerator, and the denominator is the base, but now the same exponent is now negative. That's how it works. So I hope that this was useful for you, and that you can find some practical application of this. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.